welcome everybody to the Fermyon October community meeting. We'll just cover over a couple of things real quick, just some house rules. So essentially we're going to do some introductions around the team. Be a good opportunity for you to just put a name to a face and see what people are working on. And we're going to be doing a persistent storage demo. So I'll be running you through some Redis publishing and listening, and also some setting of persistent data on a Redis data store using WebAssembly. And following that, we'll have some questions and answers, and that'll be interesting. So any queries during the talks, and then or any ideas or new products that you're working on or need help with, or any of our things that we offer that you would like to find out more about, please feel free to jump in on that. Just a quick announcement that we will be recording this meeting. So if you're happy with that, stay on board and let's get into it. So we'll kick off with a introduction of the Fermyon people, Fermyon friends. I guess, Mikkel, do you want to go first?
Sure, I can do that. Thanks, Tim. Yeah, so I'm Mikkel. I'm leading the development business across Fermyon. And I'm based in Europe. I'm based in Finland. Let me hand this off to you, Karthik.
I started as a summer intern, and I'm continuing my internship in software development through the fall quarter right now. I'm based in California in the US. And do you want to take over, Rajat?
Hey folks, I'm Rajat. I joined Fermyon this week, and I joined as a senior platform engineer, hoping to work on some of the open source stuff as well. I'm based in India, in a very small town. My hometown is like near Chandigarh. I don't know how many people have heard about it. It's a very small town near Chandigarh, and very excited to be here and part of the community. It was always a dream to be part of a community like this, and I'm really glad that this is complete now.
I'm Radu. I'm the CTO of Fermyon. I live somewhere in a mid-Atlantic time zone, never fully awake, never fully asleep. I'll just leave it at that. Tim?
Perfect. Thanks, everyone. So yeah, I guess I'll jump right in. I'll share my screen and we'll get in and do a demo. All right. So this is based on a recent blog post and also a follow-up video that I did. I'll just share my screen and then make sure you can see it before I keep going. All right. Okay. All right. So yeah, as I said, this blog post, this persistent storage and WebAssembly applications blog went out on September the 30th. And there's a follow-up video on YouTube. You can check that out on the Fermyon YouTube channel. But we're actually going to go through the blog today and do it live as a demonstration. So basically this talks about obviously storage being an important part of an application, and mentioning a bunch of different things, from as simple as like a game's high score that you'd want to keep day after day, to complex inventory of a business and so on and so forth. So storage is an important part of any application, and there's a couple of different storage solutions that we're working on. One is the Redis, which is what we're going to go through today, and the other one, we've been doing a fair bit of work with not only Postgres but also .NET applications using WebAssembly and that integration of that whole ecosystem. But today we're going to do a spin application using Redis, and we're going to do it in two parts. One is going to be publishing and listening, so on a Redis channel, and then after that we're going to actually just store and retrieve values from a Redis data store, and then do a full persistent save on that. Okay, so depending on whether you've used Spin yet, let's actually just go over a couple of really quick basic features first. So starting with Redis, I've just got a couple of terminals here that we've prepared. So we can start up a Redis server, which will look something like that. And the Redis command line interface will start like that. And that'll just give us a command prompt on localhost. And this is all described in the blog here. You can install Redis and fire this up in a couple of minutes, so you can go ahead and do that in your own time, or watch the video like I said. But for now we'll continue through. So once you've got the Redis command line interface running, you can just go ahead and practice a little bit, depending on whether you've used it. So in here we can do things like set num, and we'll set that to 0, and we can do things like increment that number and it'll automatically increment that. So now if we do get none, we'll see that that's been incremented from 0 up to 1. So this is just out of the box Redis functionality, and we'll come back at the end and actually use the command line interface to check that our data's been stored via the WebAssembly applications. So speaking of WebAssembly applications, we're going to create a spin application. So we'll go back here to this first terminal, and if we type spin, and we want to actually have a look at the templates that are installed. So if we type templates list, that will show us that we've got a bunch of templates installed already. Now, if you don't have those, you can go ahead and run a command like this, which will go ahead and install all of the templates from the repository. But I already have those installed anyway, so that's fine. So what we're going to do is create a new Redis trigger example now. So we do this command here. So it's a spin new, and it's the Redis Rust type of application, and then we're going to call the actual application Redis trigger example. All right. So the project description, a new app. That's got the Redis address already put in there by default, and the Redis channel, we'll call this channel 1. All right. So now we have that, we can cd into that, and we'll see here that we've got the spin.toml file. All right, so in here, the spin new command has actually pre-populated all of this information for us. You can see the channel here has been filled in. The target for when we do compile our Rust code to WebAssembly that'll be the location of that. And we have a trigger. A type here is Redis. So essentially what's going to happen is when there's activity on Redis on localhost, specifically on channel 1, it's actually going to execute this WebAssembly file. So let's have a look at the source code that's actually going to run. So this onMessage function is essentially what's being compiled to WebAssembly, and at the moment it's outputting the message that is published on a Redis channel to the logs. So let's tweak this a little bit. Just have a look back here at the blog post. We want to perhaps see this in the command line interface when we spin up the application. So let's grab this print line statement of Rust source code, and let's pop that in here. All right. All right, so put that in there. We can see here that the message comes in, so we'll just change that to message. So what's going to happen now is this will execute. It'll print the message that's been published on the channel. So we'll save that. Now the next step is to build the application. So by doing the spin build command, let's have a look here. We actually see that if we do spin build, it will run this cargo build with the WASM32 WASI target. And so let's do spin build. So the next thing we're going to do after this is run it using spin up. So we'll go spin up. All right. So we've got that running there. There's a spin application running, and we'll go over to the command line interface for Redis. And what we're going to do is publish something on that channel that the app is listening to. One, and we'll call that. All right, so we've published that, and you can see here this integer 1. That means that one thing is listening, and that would be our spin application. So if we go over here, we can see that that is in fact happened. The activities occurred on the Redis channel, and the application has triggered the WebAssembly to run, which in turn printed out hello community meeting to the terminal. So that's great. We're going to leave that going, and we're going to come back to it in a minute. But for now, let's go over to try a different example. And we're going to sort of tie these examples together just to make it a little bit interesting. So the persistent storage part is slightly different. So essentially what we've done then is published and listened on Redis, so via WebAssembly application. So what we're going to do now is a persistent storage example, and we're going to tweak that original project to do some, basically down here we have some setting and some getting of values. So let's go ahead and do that, and that'll give us a good opportunity to understand how it actually works. So the simplest way to do this would be to copy. I am in the wrong directory. I'll just go back up. So we'll copy this guy, and we'll call it Redis System App. Right. So in here, obviously the same structure and everything like that. We're going to just make a few little tweaks. So the first tweak is in the spin.toml file, and there's the component. And what we want to do is we want to fill it with this following section here. So this will create a route called publish. So when we visit localhost 3000/publish, that route will actually trigger activity. And instead of the original file having the trigger of type Redis, we're actually going to change that out and have the trigger of type HTTP. So a slightly different take on the app. So let's grab this code here, and in our new persistent app, we'll buy the spin.toml file, and here. All right, and as we said, this original trigger type of Redis, we want to switch that out and actually make that a HTTP. In here, there it is there, the trigger. So we pop in this new line. All right. And from there, the cargo.toml file, which is the dependencies, we're now using a new one. So in this case, HTTP. So what we might do just for presentation purposes is just grab all of this. Yep. And we'll just replace those. Okay. All right. So at this point, we've got the spin.toml and the cargo.toml file sorted out. And now for the lib.rs, so this is the Rust code that gets turned into WebAssembly. Let me just go down here. I'm not using my mouse, I'm using my trackpad, which is a little bit clunky, so excuse me for. All right, so we go via the source lib.rs file, and in here, obviously, initially we had this really basic on message, which just did a print line and printed to the logs, but we're actually going to change that quite significantly, and we're going to have this more complex function here called publish. And as I said, when you go to the localhost 3000/publish, this is going to execute, upon the request to that endpoint. And what it's going to do is a few things. It's going to grab the address and the channel from the environment variables that we've set. I'll just actually show you that because that's interesting. So by spin.toml, see in here in the component, we've got an environment section and we've got a Redis address and Redis channel set in there. So it's actually picking up those values and setting them in here. Now, the first thing it does is it goes and gets a key called myKey from the Redis data store. So let's actually go and set that over here. So it's called myKey. So if we put set myKey to all right, so we've set that. The next thing it does is it sets the spin-example key to the word Eureka. And then what it does is it sets an integer key and it sets that to the value of 0. And then after that, it uses the increment function to increment that 0, obviously, to a 1. And as you can see, there's an assert there that ought to equal 1. And then the last thing it does is it publishes the variable from up here, this payload that we've got on this line. It actually publishes that payload to the channel, which it knows is channel 1. As I just showed, we're picking up the channel and the address from the config. So that's all good to go. So we just need to go ahead and build that. All right. So we run that, and by rights, we haven't actually gone to the publish endpoint yet, so we won't see any activity here. We've still got this first spin application running that's listening on channel 1, but nothing's actually happened yet because we haven't visited the URL. So let's go ahead and do that. So this here, if I hit enter here, what we'll see if we go back is we've got this event here that's actually now printed out the value of that key to the terminal. And the last thing that we can do is just have a look in here at these different values. So we've got a spin example. So if we go to here, we get spin dash example, and that will be Eureka. And this int dash key, which started at 0 and got incremented to 1, we can get that as well. So that'll be 1. So that's all working correctly out of the box. And I suppose we could go and get the my key, but we already know what that's going to be. That'll be that. Okay, so essentially what we've done there is combine a couple of different functionalities with Redis, so we can set, increment. And as I mentioned at the very start, there's a bunch of out-of-the-box Redis command line interface commands, and these have been implemented in the Spin SDK's Redis implementation. So this makes it super easy. If we're looking at this source code here, to actually just call Redis get, Redis set, Redis increment, and so it's that easy. And you can code this up in your application. Now, the last thing to show you for proper persistent storage, if you just actually type the word save, what this does is it saves that physically to disk, and you could shut down this entire server system, reboot the machine from scratch, power down, power up, and if you start up your Spin applications, everything will persist and will work as well as before you shut it down. So just at the bottom of the blog there, we've got a bit of a explanation about how to do that. It's obviously very simple. Just typing the word save is enough. So Redis is fantastic, and the way it's been implemented into Spin is brilliant. And so go ahead and have a play with it. Watch the video, read the blog. Hope you enjoyed that demo. I will unshare my screen and okay, get back to it. All right, so
there's a question in chat about various other operations you would be able to do from Spin in Redis. Currently, we implement get, set, publish, and then subscribe through the trigger. And I think we also implement delete. We're just trying to go through the most popular operations you would do in Redis. So if save is something you want to do on a regular basis, we would be definitely open to extending the interface for the Redis implementation. That's not currently implemented.
What are the other data stores that we have support for today beyond Redis?
So Postgres, we have been working on a bit of that today in a .NET environment, actually creating proper structured query language database tables, and going ahead and with help from Ivan, that was brilliant today. We had a good play with it, and we're essentially able to interact with the Postgres database and have the Spin application perform all the operations and even print it up to the browser, so the applications interface, which is really cool. And so really now it's time to come up with an application idea and build that and document it. So between Redis and Postgres, those are the ones that are well implemented, and you can actually create something quite useful.
Cool.
There's one other thing with relation to Redis. I think expanding the types of data you could put in it, like moving towards, because Redis has native JSON functionality. So rather than having to pull out a blob and open it up and perform custom operations on a JSON object, it actually has them built in. So that would be something perhaps worth looking at in the future, is to actually have the Redis implementation in the SDK able to just talk JSON to the data, which would be, I'm guessing, way more efficient, which is why it would have been created. So you're not lugging blobs around. You're actually just going to perform operations directly in line. So that would be handy.
The other thing I want to point out is depending on various SDKs for stuff like cloud services, you could theoretically, and we have examples of that, of using, for example, Azure Blob Storage or Azure Cosmos DB to get and post document and JSON collections to Azure Cosmos and other Azure services as well. And if you're interested in how that works, we're happy to point you to an SDK and an example of how it works.
Yeah, and I suppose it depends on what you're trying to do as an application developer, what you're trying to build, whether it's super lightweight. I know that Mikkel implemented the game high score using, is it JSON bin, Mikkel? To just basically throw a really small amount of data against it, like a paste bin type of deal over HTTP, which Spin can obviously do those requests and responses. So I thought that was neat. Yeah, you don't need to over-engineer it. It's just a single value game high score.
But it works well for the use case, right?
Yeah, hey, it works. Yeah, it's great. Yeah.
Radu, awesome. Those examples that you mentioned, are those in the kitchen sink repo, or where would we find those? Or is it branch hunting to get to them?
It's not branch hunting. It's one of, I think it's in one of a JS Labs repos that we worked on a while back. So let me go hunt one of those.
Cool, thanks. Yeah, and that was a little bit of a plug for the kitchen sink repo that we have in our Fermyon organization at GitHub. If you are looking for sort of like outliers of examples or some complex operations and stuff like that, we have this kitchen sink repo that's pretty interesting. You can find stuff that we haven't done a good job at documenting yet, but there is some good examples there.
So I'm working at the moment just on a little experimental app, because I think it's an interesting idea with WebAssembly being able to run so efficiently and also run, on a triggered basis. It's a cooking thing called could cook. Like, if you had these ingredients, what could you cook? And so it's essentially a database of ingredients and a database of recipes. And if somebody adds ingredients, it will, in real time, re-evaluate what you could make with those ingredients. And I think it's like, just as I think about it, just as an aside, like as an application to just demonstrate, like with Finicky Whiskers, the game, it's kind of like spawning up, WebAssembly microservices and things like that. I think there's other elements of it which could promote reuse. For example, you have conversions from metric to imperial and back, or like, a cup versus how many mils, or all these sorts of cooking measurements. You could have that all predefined in a matrix, and so if somebody puts in a cup of flour, it would just know that it's so many grams, which is so much quantity, milliliters, grams. And I think that would be really interesting to just build out a whole good cook site where you can come along and punch in all your ingredients and go, what can I make with that? And then people could come and put recipes in. Anyway, it's just a fun app. The other idea is supply chain things where you have raw ingredients that can turn into sub ingredients. And Matt and I were talking, like if you had, like beads that go on a string and that makes a bracelet, and then that becomes part of a some jewelry or something, you can like build up components like that in the real world, and things might have lag times or shipping delays, so it'd be interesting to just come up with a supply chain example of, and build it all through multiple microservices. The example in the blog, there is a section that I didn't cover So it's not really about persistent storage, but it was just covering running microservices inside. Did a rock paper scissors example, and you can see that in the blog. So if you hit the rock endpoint, it'll return something. If you hit the paper endpoint, it'll return something different. But it's all part of the same spin application. It's all inside there. So multiple microservices running on the one application, and it's obviously super lightweight, super fast, and flexible, and yeah. So bit of fun.
Cool. If anyone has we could do a round of what's the last spin application you built. The last time you did spin, what came out of it. I'll be happy to go first. I built a totally useless to-do application, which basically has this nice feature that you're not able to complete any tasks, which I think is pretty realistic. The main thing that I wanted to get out of it, I'll just find the link and share the repo later. The main thing that I really wanted to get out of that application was trying to figure out with a spin application, how is a good way to have sort of like a front end, back end set up between two components. Thank you, Radu. So basically having a front end using the spin file server to just serve static content like the HTML, the JavaScript, the CSS, and all of that. And then also having an API being hosted in the same spin application, but have those be two different modules serving them. I think that's a pattern that can become really, really useful. And maybe there's stuff in the file server we should optimize on that one. But yeah, that was a fun one to do. It doesn't do anything in the backend though yet, but it could if we wanted to.
Yeah, that's a good point. Once you start combining them, that's what I found with Redis, is that you've got a HTTP style like a trigger, and you've got a Redis. But if you can actually do all of that and incorporate a front end, it becomes really powerful once you can build all that out and to function together in the same application. Initially, my thoughts were, I'll just run 2 spin-ups. But then I'm like, well, hang on. Maybe we can figure out how to, like using the file server and things like that, to like build it all into the one, which is essentially like what Bartholomew does. It does a lot of things with a lot of different components. For people who may not know, our Fermyon.com website is built, it's entirely powered by WebAssembly, so the Bartholomew code is in our GitHub, and it's essentially a content management system, and it's powered by WebAssembly, like a Bartholomew.wasm file. What I find really interesting is upon every request, it reacts. So for example, if a web crawler comes and asks for the sitemap or the robots.txt file, this is all dynamically generated in real time. So it's not like a static site generator up front. It actually happens upon request. So everything gets rendered, all the images or any sort of activity, and we use Rye scripting as well. So all the content's written in Markdown. It's a really brilliant application. So it's super easy to write articles and blogs and websites, and then it's all just powered by WebAssembly, but super lightweight. So at the end of the day, what's really awesome about it is there's nothing actually running until a request comes in, which is what I find really powerful. So there's no energy consumption until the request comes, and then it responds appropriately, and then it's very much that virtual machine, that standalone stack-based, ephemeral machine that executes and vanishes. So I love that about it. Anybody got any ideas about things they'd like to build? Or things that you on your wish list or your laundry list?
Yeah, for me, it's using relational databases more. That's what I would really like to see in more of like examples, and us building better support and a spin for it.
Yeah, that would be amazing. Then the sky's the limit, right? It's as you've already seen, you can do so much already with.
Do you have any ideas, Radu, on the direction for that? Because I think the way that we've done some of these now, we have those, like we're not using, how closely is the stuff that we implemented for Postgres? And I'm asking because I haven't spent a lot of time looking into this, as to using a Postgres SDK in the same programming language, but not in a spin application. And what do you think is the direction we should take there?
So there are 3 main things I want to point here. One is the implementation that we have for something like Postgres right now in Spin is fairly low level, as in you work with really the actual Postgres types, so you don't really have any sort of high level code generation that you would get, for example, in something like .NET, where you would have something like Entity Framework that automatically generates code for your database based on your actual typed code in .NET. So we don't have that working yet. So you're still working with raw Postgres types back and forth. We are exploring a few directions there to have code generation, but it's going to be very dependent on each programming language. So we also want to avoid building our own ORMs in each programming language. So the actual direction we hope this will end up taking is most databases either talk over TCP or HTTP. If they talk over HTTP, then Spin can talk to them direct using the outbound HTTP implementation. So we have a way of talking to them. We have experiments working with PlanetScale, for example, which has an HTTP API, and that's working really well. Thanks for that, Karthik. And we're essentially trying to use existing libraries that work with databases over their transport. If it's HTTP, it's excellent. But most databases have drivers that talk over TCP. And that means we either go the route of implementing what we currently have with Postgres, which is low-level types back and forth through a Spin host implementation, or hopefully soon we'll have the WebAssembly networking spec implemented in Wasmtime, which we're using in Spin. So we would be able to just natively connect to a TCP endpoint from a WebAssembly module. So once we have that, we should be able to use existing ORMs and existing database connectors to just use them from Spin. So we wouldn't have to re-implement stuff like serializing back and forth across the hosts back and forth ourselves. So currently, the manual implementation of, for example, something like Postgres is a stopgap, and we hope that really soon we will have real database drivers back and forth. In the meantime, if you're using something like PlanetScale, we might have something working really soon for that. Was that any clearer on the direction?
Yeah, for sure. So at the moment, I see in Postgres, we're writing the select statements in SQL and basically doing that. So any sort of security things you have to implement in the application developer has to implement, which makes sense. Like that's how it's normally done. So
we do build the minimal things such as making sure you don't do injection and stuff like that. So we do look at some of those, but obviously not at the level that an ORM would do for you.
Yeah, right. Gotcha. Yeah, that's excellent. Anybody got any ideas for things to build on an application level that we could build that maybe you don't necessarily have time for or resources or something? Just, I'm always interested to learn about. We've had a couple of different ideas. I know there's that new, well, I don't know how new it is. It's, I think it's called Be Real, where it messengers everybody on the app, and you have to take a photo of what you're doing right then. You have like 2 minutes or something, and if you don't take a photo, then you're not being real. So it's kind of like everybody takes a photo at the same time of day and uploads it to this one application. And I think that's really interesting because that thing would get absolutely inundated, and then it would have no activity for the rest of the 23 hours and 58 minutes. That's an interesting application to build. It would just be like under heavy load for a few minutes and then nothing. We have some really impressive load testing going on internally and performance and things like that. And I think that's really a brilliant WebAssembly use case. I guess even things like building an image analysis. So like looking for images that are, G-rated or what have you, like really quickly going through and finding patterns in data using WebAssembly to do it very efficiently. And I think that would be a pretty amazing use case.
Yeah, I just would like to say that I have a small application that crawls one website that the user provides, and that is performed via a SIM message and then the content is updated behind the scenes. So that's also an experiment that I'm doing with Redis PubSub. It's still very experimental, but yeah. And the other thing that I was thinking now is that given that Mongo Atlas, I think, provides an HTTP API service, it could be that you are already covering MongoDB. Yeah?
Right.
If you allow forwarding.
We haven't yet. So if you have a link to the HTTP API that they provide, we should definitely look into it. I would be really excited to have support for Mongo.
Yeah.
Absolutely. Yeah.
Yeah, I will check it out. I think there is something about that. I don't know if it's only the administration API or it's also about the databases API.
Cool. Can you talk a bit more about your app that you just mentioned? Just go into a bit more detail for us, please.
Yeah, so basically what I'm doing is that very often I find, well, I'm self-educated, so I have studied computer engineering a while back, but still realm technology is evolving very, very aggressively all the time. So we have to upgrade our knowledge very often. So what I do is that I go try to find out, for example, about WebAssembly, which is a topic that I have very much lately in mind. I have different resources from different places, and what I try to do is organize those resources. But not only in the sense of gluing some bookmarks or things like that, but also giving shape in the way like a wiki, for example, things like that. But what I would like is that if I'm collecting pieces, like websites, that these pieces are being indexed somehow. Mm-hmm. So that when I go to this portal, I can search and find information back and reference to it and use it for building knowledge, basically, which is what I like to do. So it's an application for autodidacts. I don't know if that's a word in English, by the way. If not, it's Spanglish. So
yeah, that's yeah. I didn't get that word. So yeah.
But, so self-learners.
Right. Okay. Right. Yeah. Perfect. Excellent. Yeah. Because there is so much information, right? And sometimes you just want to park it and come back to it. You don't have time right now, but put it over there, come back, find it later. That sounds awesome.
Yeah.
Yeah. Cool.
And basically build a tree. So you start with a root, and then from there on, you follow these leads, and you start to put leaves on it. But at the end, you still need the main component, which is going to be this river of information that is going to flow. So that's basically what it tries to do: organize that information in a natural way, or what I find as natural. So I'm going to see if a couple of people want to test it out, and if so, it could be something that people will use.
I have a question. What data types are you using to store? Are we? So what
at
the
moment, the main thing is still Node.js. Yep. The only thing that I have started to do is just basically do the PubSub with the spin component. So for that, for the crawler, for sending a message to the queue, and then crawling the information from the website, and then updating the information, things like that, is the only thing that I'm doing in a PubSub way.
Gotcha.
Mm-hmm. Cool. The rest is Node.js still.
Okay.
So I use MongoDB. That's what I use.
Okay. Excellent.
May I ask what programming language you're using for the spin part of it?
Rust.
You're using Rust. Okay.
Cool.
Yeah, I'm using Rust. I love Rust. I would like to use it more.
Awesome. Thanks.
Yeah, cool. Yeah. That's good. Thanks for sharing. That's awesome. Yeah. And if you want any help, I see you in Discord and things, but yeah, just reach out because we've got a whole team. There's, this is a particular time zone, but we've got some really incredible people working all around the world, and there's something different that everyone else will know. That if you have a specific question, we'll find the right person to answer it at the right time of day.
Sure. Thanks. Very good. Thanks.
Yeah, we Mikkel the other day was working out, because we're distributed all around the world, the time from when the first Fermyon person wakes up to when the last one goes to sleep. Was it like a 44-hour window of time, Mikkel? something like that. So we've got a really good spread of time zone, goes around.
A Fermyon day is a 44-hour day, which is absurd, to be honest.
Yeah.
But that's just the way it is. So yeah.
Yeah.
Nice.
Yeah. Cool.
Great talk. Thanks, man.
So yeah, 100% remote. So we're living it. But this is great. Hey, to connect and catch up and be able to chat is brilliant. Yeah. Thanks for joining us, everybody. By the way, it's really cool.
So how many got a chance to go to the big KubeCon event in a few weeks in Detroit? I know we'll be there, and there's a Wasm Day event on Monday, but I just wanted to hear if anybody else has had the opportunity. No, if not, then I think the Wasm Day is gonna be. Is that gonna be? Do you know, Radu or Tim? Does anyone know if that's gonna be streamed?
It was live streamed in Europe, in Valencia.
Okay.
So I'm assuming it is going to be live streamed as well.
Yeah, definitely check out that Monday. What is it? 24th. Yes.
October 24th.
October 24th
Yep.
for live streaming from the Wasm Day. It's going to be really, really good.
Yeah. So we're going to have people from Fermyon talk about Java and C# and a bunch of other things for WebAssembly. So if you're interested in any of those, and there are going to be a ton of really cool sessions at the event.
Yeah. All right. Okay. Well, almost at the hour. If anyone's got anything else to add, we got some time, but otherwise that's cool too. Thanks for watching. Thanks for listening. Any other comments or questions or?
Thanks for the demo, Tim.
Yeah, thanks.
Nice walkthrough.
Hopefully do a few more, and as we build upon these things, they'll be good. And I'll keep going with this could cook thing because it'll be interesting, I think. Because it's interesting. It's like when you start building it, that starts raising questions. You're like, oh, wait a second, and that's what led to the Postgres. I was like, this needs a relational database to be super efficient, and it transformed from a very simple app into a full-blown .NET. Now it's just like, let's just go and boost it all.
And expanding on that, we really want to hear about the stuff you're using and you're building with Spin, and if there are things that you are bumping into that could be smoother, or features that you would really like to see, and really reach out. We have the show and tell channel if you just want to show something you built with any of the technology, or really any of the other channels. For you to have conversations about feature requests and bugs and things that could be better. So we really appreciate any feedback you have there.
Yeah, for sure. And all of the team are great. Ivan's closest to me in New Zealand. Like, we're only a couple of hours apart, but I just love reaching out to him, and he just comes in with a fresh perspective and a bunch of knowledge, and you can be stuck for a little bit. And if you just ask, it's like resolved in a few minutes. I always sort of hold off going, I'll just keep trying myself for a bit. But yeah, the team are brilliant, and everyone's got their own set of specialities too. So please reach out. Don't suffer in silence. If you have a roadblock, just hit us up, Discord, GitHub, wherever. Yeah, put an issue in.
The other thing I was going to mention was around documentation and feedback for documentation. So we're always looking at making that better. So if you have thoughts what could be improved or stuff that is missing from the current quick starts and guides, please reach out.
Okay, thanks once again for joining us. We'll be back in another month. The next time zone is shifting, and we'll be back to this time zone the following month. We're just alternating back and forth. So keep an eye out on Discord, and see you online. Thanks so much for joining. Okay, bye.